Chapter 110, Cube Roots. So in 1.9, there was a list of perfect squares, and I told you to memorize them. Here's a list of perfect cubes. You need to memorize these two. So a cube is, instead of multiplying 2 times 2, getting 4, that's a square, we're going to multiply 3 of them. Just kidding. 2 times 2 times 2. 3 times. Well, 2 times 2 is 4. 4 times 2 is 8. So 2 cubed, or 2 to the third power, or 3 2's multiplied together is 8. Please do not make the mistake when you see 2 cubed and tell me that it is 6. It is not 2 times 3. It is 2 cubed, meaning 3 2's multiplied together. Think of a cube as the shape. If you have a shape of a cube, all of the sides are the same length. So 2 wide times 2 long times 2 units high would get you a total of 8 units. 2 times 2 times 2. That's why we call them cubes, because if I were to stack units, stack blocks, 2 blocks high or 2 blocks wide, 2 blocks tall, I would need 8 blocks. 4 for the bottom, 4 for the top. So let's find the cube root of each of these numbers in example A, or example 1. So A, I want the cube root of 8. Well, there is a symbol. You all know the square root symbol, right? The cube root adds a 3 right here. This is called the index. You don't need to remember that right now. You can remember it later. This is called an index. This means I want the cube root of 8. So looking at my chart over here, the cube root of 8 is equal to 2. 2 times 2 times 2 equals 8. So B, I want the cube root of negative 125. Well, since I know that a cube is multiplying 3 things together, the cube root of 125 happens to be 5. But I want to get a negative 125. So the same number needs to be multiplied 3 times. So if I have 5 times 5 times 5, I'm going to get a positive number. If I change all of these to negative 5 times negative 5 is 25. But 25 times negative 5 is negative 125, because a negative times a positive is a negative. So the cube root of negative 125 is actually negative 5. All right, and C, the cube root of 1/64. Well, I'm going to take the cube root of the numerator, and I want the cube root of the denominator separately. Well, the cube root of 1 is always 1. The cube root of 64, if I come over here to my chart, is 4. So 1/4 is the cube root of 1/64. All right, let's take a look at example 2. A cube-shaped packing box has a volume of 64 cubic feet. What is the side length of the box? Well, since this is a cube, I have a side times a side times a side. They are all the same. So side times the side times the side is the same as saying side cubed, which equals 64. So 5 side cubed equals 64. I want the cube root of both. So my side is equal to 4 feet. It's a pretty big box. 4 feet by 4 feet by 4 feet. But one side will measure 4 feet. Each side will measure 4 feet because it's a cube and all of the sides are the same length. So final example, example 3. X cubed equals 8 over 343. When it says solve, this means I want to know what does x by itself equal. So in order to solve this, I will write the original problem. I'm going to take the cube root of x and the cube root of 8 and 343rds. So x equals, take the cube root of each of these separately. So the cube root of 8 is 2. The cube root of 343 is 7. So x equals 2/7. I can check that. If I multiply 2/7 times 2/7 times 2/7, 2 times 2 is 4 times 2 is 8. 7 times 7 is 49 times 7 is 343. So this does check out. Okay, that's it for examples. Use that chart on the previous page. It's found on page 55 in your book. That will definitely help you and memorize those perfect cubes. All right, complete your QCs and CYUs. And if you have any questions, please come see me.